Linear Algebra, Episode 1. What is linear algebra? Have you ever wondered how Google Maps finds the shortest route, how Netflix recommends movies you might enjoy, or how robots and self-driving cars understand the world around them? Although these technologies seem very different, they all rely on one powerful branch of mathematics called linear algebra. Welcome to the first episode of our linear algebra series. Whether you're a student of mathematics, computer science, engineering, physics, or data science, this course is designed to help you understand linear algebra from the ground up. You don't need advanced mathematical knowledge, just curiosity and a willingness to learn. Let's begin with the most important question. What is linear algebra? Linear algebra is a branch of mathematics that studies vectors, matrices, systems of linear equations, and linear transformations. It provides mathematical tools for solving problems involving many variables and for describing relationships between different quantities. At first, this definition might sound complicated, but don't worry. Throughout this course, we'll learn each concept step by step with simple explanations and practical examples. Now let's understand why it is called linear algebra. The word linear refers to equations in which each variable appears only to the first power. For example, the equation x plus y equals 5 is a linear equation because both variables have an exponent of 1. These kinds of equations describe straight-line relationships and form the foundation of linear algebra. The word algebra refers to the branch of mathematics that uses symbols, variables, and equations to solve problems. When we combine these ideas, we get linear algebra, a mathematical framework for studying linear relationships using vectors and matrices. But where did linear algebra come from? The origins of linear algebra go back thousands of years. Ancient civilizations such as the Egyptians and Babylonians solved systems of equations while measuring land and constructing buildings. Later, mathematicians in China developed systematic methods for solving multiple equations. During the 17th century, René Descartes connected algebra with geometry, opening the door to coordinate geometry. Over the following centuries, mathematicians introduced vectors, matrices, and many of the ideas that make up modern linear algebra. Today, linear algebra is one of the most important subjects in mathematics because it is used almost everywhere. In artificial intelligence and machine learning, data are represented using vectors and matrices so computers can recognize patterns and make predictions. In data science, linear algebra helps organize and analyze massive datasets. In computer graphics and video games, it is used to rotate, move, and scale 2D and 3D objects. In robotics, it helps machines understand position, movement, and direction. Engineers use it to design buildings, bridges, aircraft, and electrical systems. Scientists use it to analyze experiments, while economists use it to model financial systems. As you can see, linear algebra is much more than a university subject. It is one of the mathematical foundations of the modern world. So, what will you learn in this course? We will begin with the basics by understanding scalars and vectors. Then we'll study vector operations, matrices, matrix multiplication, determinants, systems of linear equations, vector spaces, linear independence, basis, dimension, eigenvalues, eigenvectors, orthogonality, and many other exciting topics. Every lesson will build on the previous one, so I recommend following the series in order. By the end of this course, you'll not only know the formulas but also understand why they work and how they are applied in real life. Thank you for joining me in the first episode of this linear algebra series. In the next lesson, we'll begin with the fundamental building blocks of linear algebra by exploring scalars and vectors. Until then, keep learning, stay curious, and remember, every great mathematical journey begins with a single question. See you in the next episode.